Hi everybody, Scott Stanchfield here. Let's take a look at the Kotlin language from the point of view of Java. Now I'm going to assume that you know Java very well here, all the concepts behind it, the way the language structures work, and some of the libraries, things like using lists and maps. Other than that, I'm going to talk about a lot of the details in Kotlin that you might not have experienced inside Java. So first of all, a few concepts. Kotlin can run on the Java virtual machine. What they do is they just create Java code behind the scenes for anything that you compile in Kotlin and actually run it on the virtual machine. So you can interact with existing Java programs or Java frameworks such as Android. You can also run it on JavaScript, which is fantastic because you can create your web applications using Kotlin. A lot of the same code will work in both spots. The main difference is going to be how you define user interfaces. You can also use it on native platforms, so whether you're doing on Windows or Linux or Mac or even on iOS. Now, Kotlin itself is an object-oriented language and a functional language. You can do both approaches of programming here. Most of what we're going to be doing is using object-oriented features in Kotlin with some functional features. So a lot of times when you interact with lists and maps and other types of streams, we'll be going to a functional approach. But a lot of the interaction with Android is going to be object-oriented. One big thing to note off the bat, everything in Kotlin is public or final by default. So unless you explicitly say it's private, any class you define, any interface, whatever, is going to be public. They're also final, and unfortunately I think that's actually a mistake in the language definition. They took it from the approach of you have to explicitly design something to be extensible. My personal philosophy is that I think everything should be extensible by default unless you explicitly say don't. Unfortunately, Kotlin took the final by default approach, and you have to explicitly mark things as open or abstract to be able to extend them. That said, let's go ahead and take a look at some concepts and some examples between two different languages. I'm going to start with, on the Java side here, we're going to create some classes and show you the equivalent of them in Kotlin. So let's first of all start by creating a person class and all the types of things you might do with a typical person class. So first of all, we're going to define a name and an age for the person. And we'll say private string name. And it's going to take me a little while to remember to put the semicolons in there all the time. And private int age. So those are a couple fields we're defining to hold the data of the string and name and the int age behind the scenes. Now let's go ahead and create getters and setters for it. And I'm just going to use some assistance in the environment here. For this example, I'm using IntelliJ, the actual IDEA environment, and not the Android Studio. There's a little bug in Android Studio, the version at the time I'm recording this, where you can't run things as easily inside if you're just running a straight Kotlin program. That won't be a problem for your Android development, but for this example, I'm running it in this, and you should be able to import this project and look at it. I'm going to go ahead and create getters and setters for both the name and the age, and boom, you see now we have our get and sets for all those guys. And let's also create some functions that you normally would create here. An equals function, a hash code, and a toString. So we'll come in here and we'll say equals and hash code. And I'm going to apply the equals and hash code to both the name and the age because I want to compare both of them. And name, I'm going to let name be nullable. So now you can see how the equals and hash code have been defined. And let's also define the toString function using those two fields. So we have the person, name, and age. So that is a typical data object. We might call this a plain old Java object that you would define in the Java language. And you can see in Java, it's very, very verbose. One of the things I love about Kotlin is how simply you can do exactly what I did with just a very few little words in here. So I can come over here and I can say data class, person, and then var name, colon string, and var age, colon int. And poof, I'm done. That's the entire equivalent definition that I just did on the Java sample side. And it adds a couple other features, which I'll talk about later, probably at various points during the course rather than this primer. But what this data class does for us is any fields, any properties that we're defining inside the constructor for the data class are automatically backed by data fields and have getters and setters defined for them. Now, you don't exactly call them the same way you would in Java. The syntax for calling them is a little bit simpler. Let's take a look at a little main function here. And notice that in Kotlin, I can define a main function up at the top level of a file. I don't have to put it inside of a class. And what it does for running this on the Java virtual machine is it actually creates a class called Kotlin sample KT without the dot there and an uppercase K. And that'll actually be a little dummy class that it uses to hold all of these top level functions or variable definitions that you might define. So inside here, I can say, let's go ahead and define a person. I'm going to say, give me a person. And inside that constructor, I'm going to say, my name is Scott and my age is 54. And then if I wanted to, I could change those things or print them. So let's first of all print them. And we'll say println person.name and person.age. Or if I wanted to print the entire person at once using its toString function, I could just say println person. And if I wanted to change these, I could say person.name equals Stephanie and person.age equals, I'm going to say 0 because I don't want to tell anybody her name, her age. And then we will print out the same information again down here. So person, name, and age. And let's go ahead and run that. Now, the thing I was mentioning with Android Studio is this little run button doesn't work correctly in Android Studio, the version that's out right now. Make sure whatever versions you're using are what matches the syllabus. I'm going to run this. And let's take a look at what happens here. So we'll see down here we have Scott 54, and then here's that toString. And then Stephanie 0, and there's that toString being printed out. So that works just fantastically. And you'll notice how very little code I had to write there. The equivalent in Java is a little bit more verbose. Here you'd have to say person get name and get age. Here you'd say person set name, passing in Stephanie, person set name, set age, and so on. So it'd be a little bit more verbose on the Java side. So these lines aren't really that much of a savings, but this up here is just fantastic. Now let's dissect that a little bit more. Let's start off just by talking about a really basic class, and then we'll come back to this data class and get into all the details, what's going on behind it. I'm going to say class sample. And keep in mind, again, this class is public by default and final, so you can't extend it. If you wanted to be able to extend it, I would have to say open in front of it. And then I could have sample subclass extends sample like that, and then do whatever I want there. I need a constructor call there. So in order to extend it, you have to make it open. And this will also apply for any type of function or property definitions that you make inside of that class. So inside of the sample, I can have properties and I can have functions. Now, the properties are either going to be variables or values. And that's where we have things like val, maybe I'll say x, and var, like that. And any type of values are immutable. That means you can't say x equals something. Once he has a value, boom, it's fixed forever. And then for the variables, these are mutables, and you can change those along the way. Most of the time when you have data like this inside of a class, you're probably going to want to make it private. Some things you might want to make public. So in this case, this variable y, if you created an instance of sample, you could set y and you could get y because it's public. Now let's take a look at a little function definition here. I'll come in here and say fun, we'll just call it foo. And we can do something inside this function. Let's say println foo, something like that. So using this class, we could go down into our main here, and if I said val foo equals sample, actually let's call him sample just to be consistent. And then I could say println sample.x, sample.y, things like that. And you see if I say sample.x equals something, it's going to tell me, no, you can't do that because sample is a val. That means he's an immutable value. You can't reassign him. But I can do that with y, and it works perfectly fine. So back up to this sample a little bit here. Let's think about what these values and vars do. Now, anytime you have something that's immutable, he's going to create a getter function for that value. So you can actually access it. The variable is going to create a getter and a setter. So it's kind of similar to what we define over here. If you just define a get function inside Java, it's going to be an immutable function from the outside of the person. If you define a getter and a setter, then it's mutable. Now these, the vals and the vars, have implicitly defined getters and setters for them. Now if I wanted to see what these implicit functions look like, they basically look like this. I could say get, And inside here, it's just return field. Now, field is kind of a special name here inside of Kotlin. It's not reserved, but used in certain contexts, it means things. So inside a getter or a setter, when you mention field, it's referring to something called a backing field. And that backing field is the equivalent of these privates that we set up over here in Java to actually store the value. Now, you don't have to have a backing field. You could have a value that just explicitly returns something that's the same value every time, or a computed value. So for example, if I wanted to have a val z that's just whatever x plus y is at any given point, I could say val z is an int, and then say get return x plus y. And in this case, inside the body of this get, I haven't mentioned field at all. And what that does, Kotlin says, well, you don't need a field, we're not going to create one for you. So there's nothing stored, it just returns this value anytime you mention z. So if I said sample.z, it's going to return whatever the current x plus y is. Now this is very different from if I said, I'm going to call z2. Val z2 int is x plus y. This is an initializer that initializes it once. So we're going to take whatever the current values of x and y is and store it inside the backing field of z2. And his default getter, which again looks like this, is just going to return that same value over and over and over again. Be careful in things like that. Sometimes people will think if they define it this way, it's going to act as a function. But it in fact initializes the value once, and you'll never be able to change it again. Now let's take a look at the variable side of things. So he's going to have the same kind of a getter there, but his set function is going to look kind of like this. Field equals value. And that's the default for that behind the scenes, is that we will just set the backing field to whatever value is passed into the setter. So these are the defaults for this. And you can override those. If you don't specify them, like on this guy, you'll get the appropriate default getter or setter for free that'll do its job using the backing field. This gets interesting if you actually want to do something when these values change or when somebody's accessing them. Maybe you want to log something. You could put some log statements in here to log the values accessed or the values changed. Most of the time, you're probably not going to care about the access to it. Once in a while, maybe. I mean, the most times when people override a getter, it's going to be to create a derived property, which is going to be based on the value of a couple other properties, like our z here. Z is derived from x and y just by adding them together. For the setter, on the other hand, it can be very common to set something up in there to report that a value has changed or to run some other type of function. For example, if we were doing stuff in Android and we're creating some custom graphics for a view, we might say when some properties change, I want to force the view to be refreshed so it'll change what you see on the screen. For example, I wrote a custom graph component not too long ago, and in that graph component, if any of the data coming in changes or any of the label definitions change or the time frame changes, I want to refresh the entire GUI component. So in that case, I put a little invalidate call here. And that invalidate told the view to make sure it refreshes itself on the screen. So you can do interesting things like that just by letting the setter be overridden. Now, in most cases, you're not going to explicitly override these, but it's nice to know that you can and how to do it. Now, this definition here tends to be a little bit more verbose than it necessarily needs to be. What we can do is take advantage of some of Kotlin's capabilities for defining constructors to actually define the properties inline in the constructor. So if I came up here and I said class sample2, let's say, I can define the constructor just by putting parentheses right after sample. And if you don't put the parentheses, it only defines a single constructor that has no arguments. But here I'm just going to say, I'm going to have val x is an int and val y is another int. And poof, this is a complete class definition that defines two properties, x and y, forces the user to assign them when creating an instance of sample2, so you have to pass them in, and those are immutable. They can't change. So when somebody uses these, in that sample2, let's come down here to our main and say val sample2 equals sample2. Note that it's going to give me an error here until I specify the x and y. So I can come in here and say 10, 20. And note that IntelliJ adds in a little notation there to tell us which one is X and which is Y. What's neat though in Kotlin is you can actually explicitly specify that in your own code by saying X equals and Y equals. And if you really want to, you can swap those around just like that. You can put them in any order. And this is really, really useful if you have a long parameter list. You can explicitly specify which items are being assigned to what values, and in whatever order you prefer as a caller to set them up in. And then the appropriate settings will be done along the way. Now, likewise, if we look at the constructor definition up here, you can specify default values for this. So if the user doesn't specify one of these, you can actually have a value. So if I wanted to default these both to 0, I could just put equals 0 on those. And now the user can specify only parts of these if they want to. So down in here, I could come in and say sample 4, and maybe I only specify Y, or maybe I only specify X, something like that. And that can be really useful when you have a long argument list with things that have reasonable defaults to them. Sometimes there may be some callbacks being passed in, and you might not want to initialize all those callbacks. Some of them you might not use. And so you might just not specify them. And if the constructor set up a reasonable default for it, it'll use that default. If you go to javadude.com, that's my homepage, and go to articles, I have an article called From Java to Kotlin. I was planning on doing a series here, but I just got really super busy and I haven't gotten back to it. So this first section here, though, talks a ton of detail on properties and values and variables and how you set up constructors, as well as doing alternative constructors. So if you want to get into a lot more detail on that, please take a look here. This really goes through things very, very thoroughly on how you can set up properties and constructors. Let's look at functions a little bit more detailed. I'm going to come back up here. Now let's take a look at our sample2 class that we defined our constructor. We can go ahead and define a body for that. The body may have other properties that aren't part of the constructor. So I could have val z :int equals 10. Let's make that a var. Why not? So somebody can change that. So it starts off at 10, and then the user could say whatever that sample is .z to set it to something. Now if we're defining functions in here, you just start that off by saying fun, give it your name, pass in some parameters, whatever those parameters are, and then you have a function body. Now functions can have a return type, so I can say int after that, but if you don't specify a return type, what ends up happening, let's put it up here, is the return type is actually called unit. Let me call this foo1 and foo2. And unit is just a type that means we're not returning anything from this function. It's just a unit of work. Note that the compiler is giving us an error down here on this foo2 saying you didn't have a return expression. So maybe I say return a plus 10, something like that. So this is going to have some kind of code that performs an action and doesn't return anything. So maybe we print it, println a. And then this one is going to perform some action and return it. Now you'll notice here that this has one expression returned from it. If you ever have that case where it's just one expression being evaluated from a function, you can shorthand this by using an equal sign. Something like that. And now the body has been collapsed into just a single expression. So you don't need the curly braces, you don't need the word return on there. We can go further with this because Kotlin has some really good type inferencing built into it. If I came down here and created a foo4 and got rid of the explicit type definition, Kotlin is able to figure out based on the arguments what the type is. I have an integer here, an integer here. When you add two integers, you have an integer back. Therefore, the return value of foo4 is an integer. And you can do similar things with your properties. So I can come down here and get rid of that explicit, well, let's call him z1 and z2 now. You can get rid of your explicit type definition and let Kotlin infer it, because Kotlin's very good at inferring those things. Now, these types of type inferencings also apply to things like these definitions for the getters and setters. So we could, in this particular case here, change him to just be equals field like that. And that's going to have the same kind of expression return value there. So that's not a great one to do that on. Let's come down to here. And this one actually is a real good place to demonstrate this, because now you can say, I've defined this derived property z, whose getter is just the expression x plus y. And we're just returning that. Now, sometimes you'll see people write this all on one line, kind of like that. And I'm not super keen on that type of a syntax, but it does work. Sometimes if you have a whole bunch of these, this is kind of a nice way to collapse them, but you're only saving a line here, so I'd recommend you really stick with the explicit indent and put the getter on the line like that. So let's look at some code inside of some of these functions. So if I come up here, say we're inside this function here, I can have ifs and I can have whens and I can have loops and things like that. Let's say something like if a is less than 10, then we will println a, else let's println over 10, 10 or more. Something like that. So you can do alternatives using an if statement. Whoa, I accidentally deleted that. That was brilliant. So you can have alternatives based on ifs, just like you could in other languages. If you had a whole bunch of different choices, you may want to go with a when and say something like this, when a, and you could have, if it's 1, do a println a, 2, 3, 4, and else b, c, d, and maybe a some kind of thing like that. Note that with a when, it doesn't act the same as a switch in Java where there's fall through. So if we hit this one condition, it'll only execute this print. It won't drop through and perform things afterwards. If you have multiple things you want to do for a given case, you can put it in curly braces, just like a normal block there, and do whatever you want inside that block as multiple things. So you can use these just as normal statements inside of any type of function. But where the real power starts coming in is that if and when are actually expressions. So you can use them in expression contexts. So let's say we wanted to define this foo2. Let's make a foo2a. Why not? And I'm going to define him as being when a, like this. And inside here, add in some clauses. So let me just copy some of this stuff here. And let's say I'm going to return A, return B, return C, and return D. Otherwise, the X's, something like that. And poof, we now have the when being used as an expression, where the last statement in each block is going to be the expression that's returned. So if we wanted to, I could have multiple things happening here. Maybe I println hello, maybe I do some calculations, whatever. But whatever the last expression is in this block, that's going to be the value that's returned. So based on this value of A coming in, we're going to print out different things. And this really is a game changer. You have a lot more explicit logic as far as the flow in your statements rather than having to assign variables and return them at the end or having multiple returns in a block. It makes your life a lot simpler. Now, one place where you might miss something from Java is the ternary operator, where you have that question mark and colon. With those, you have to use an explicit if statement. So if I wanted to do something like, let's say inside here, val x equals if a is less than 10, 42, else 100. So you might see something like this in a lot of places in Kotlin. And honestly, this is one of those cases where I do miss the ternary operator a little bit. Most of the time I didn't like it, because in Java, it would look more like this. which won't work in Kotlin. So this might be what the ternary operator would look like in Java. Not the most readable thing in the world, so a lot of people avoided it. But the equivalent is this explicit if-else, which is a little bit more verbose. So it's, I think, one of the places in Kotlin, one of the very few places in Kotlin, where it's a little, let's make that be int x in Java, where it's a little bit more verbose than Java is. Something like that. But using these ifs and whens and things like that as expressions is fantastic. I absolutely love doing that. Now there's some special things you can do with strings. Let me come down to this main. And let's define val x1 equals 42, x2 equals hello, x3 equals, let's make a person here. And then let's say we wanted to put these together into a string. We're going to concatenate them to make some kind of message for the user. I can just do this. Message equals, start my string, and then inside the string refer to these variables using dollar signs. So I could say x1 is $x1. Boom. And it'll replace it in line. That makes it so incredibly simple to do string concatenation. You don't have to have all these close your strings with pluses in between them like you would in Java. And maybe x2 is $x2, something like that. I'm just putting these single quotes around it just so that the string has this quotingness around it. And then the person name is, and I'm going to say $x3.name. Now notice when I did that, it put the x3.name inside curly braces. Now what's nice here is that the curly braces allow you to put a more complex expression in place. If you just had the dollar sign expression here and said .name, the .name part there is just a string being printed out. So you'd actually see the toString for x3 being printed out with .name at the end of it, and that wouldn't quite work. This is also useful if you have some kind of syntax that lumps things together. So if I wanted to say, what might be a thing? This is the $x1 time we've done this. And obviously this is not going to be the appropriate way to reference this because, you know, if you had a 1 there, you wouldn't say 1th time, you'd say 1st time. But just to show you how this works here, let's pretend that we were doing something interesting with some variables like that. In this case, it's trying to see x1nth as a variable by itself. So if we just wanted the first part of this to be the variable, we could put it inside the curly braces to explicitly delineate the end of that. Most of the time in strings, it'll be able to find where they are. Okay. Now we can also stretch strings out over multiple lines. And you do that by saying 1, 2, 3 quotes at the start and 3 quotes on the end. And this is known as a raw string. And inside here, I could say line 1, line 2, line 3, line 4, something like that. And what it'll do is all of these, including the new lines, are treated as part of the string. By saying trim indent here, which it puts in by default when you hit that enter, it's going to find the shortest indent for all the lines, and then that amount of space is going to be stripped off. So you'd actually end up seeing line 1, line 2, and then an indented line 3, and then line 4. If you want to be a little more explicit on that, you can use trim margin. And then you have to have some kind of a margin character that you use. By default, the margin character is the vertical pipe. And this little vertical pipe here just shows you where the margin is. And it just makes it so it's a little bit more explicit for where those separations are. If you want to use a different character, you can just specify that as your, actually it's a string, like something like that. And then wherever that margin prefix is, it's going to strip that off at the beginning of the line and use stuff after that. I don't tend to change that too often. Most of the time the vertical bar works. But if you're going to have some syntax that has a lot of vertical bars in it, it might be best to change it for something else, maybe a carrot or something like that. One of the best features in Kotlin is explicit nullability. In Java, they never had something built into the language that tells you if something can be null, is null a valid value or not. And that creates all sorts of issues that at runtime you have to explicitly check, is this possibly nullable or not? With what we've defined so far, nothing is nullable. So if I took a look at this person, in this person class here, string and int, these are called non-nullable types. If I wanted to make them possibly be nullable, I put a question mark after them. If I don't have the question mark, you can't possibly assign a value of null. So let's take a look at this person, for example. Let's have a person, and maybe I'll have person with nulls, just so we can see the difference on these. So if we come into here and we define a val person without nulls equals person, and let's say we try to pass in a null there for the name, notice that it's going to give us an error there. If I float over it, it's going to say null cannot be a value of non-null type string. Boom, that won't work. So I have to explicitly say some value there. And I'm just going to comment this out and say won't work. But if I have a person with nulls, then I could have a non-null value or a null value. And there's a whole lot of questions you got to ask yourself as far as, is null an actual valid value, or do I need to keep track of the fact that the user didn't specify something? I can do a whole session on just that, and when you choose something's nullable or when you choose non-null. But main thing to ask yourself is null a valid value, or should that be treated as an error? Let's say that I want to get the length of the string for the name to see how many characters are in there, in this person without nulls and person with nulls. Let's see the differences we're going to have there. So let's do a println of person without nulls dot name dot length. Boom. So we'll see that we can get the name and we can print the length out. But if I try to see the same thing with the person with nulls, notice that the lint is giving us a little bit of an error here. He's floating over. If we float over this, we'll see that only safe or non-null asserted calls are allowed in a nullable receiver of type string. When I get the person with nulls dot name, Kotlin knows that that can be possibly null. And so explicitly saying dot length may not be valid. We have to tell the compiler what our intent is here. So first of all, we could say, I know for sure that it's not null. And this is a really bad idea. You should almost never use this operator. I call it the bang bang operator. And the problem here is that we're explicitly saying, I know this is not null, which there may be a few cases here and there, but you're much better off being safe on that because this is assuming circumstances for how this variable was assigned, assuming how it's being used in other parts of your program. A much better way, do this very rarely, a much better way is to use the safe assertion operator here. And what this is going to do is it's going to say, let's take a look at everything before the question mark dot. If it's not null, keep going. If it's null, stop there, and the result of the expression is null. So what this is going to print is either the name, either the length of the name, or it'll just print out null because it won't even get to that length. And this one is perfectly fine. But what if instead you want to say, if it's null, print 0? Well, what you can do is you can add in the Elvis operator and put the 0 in here. Now we call this the Elvis operator because if you kind of turn your head, if you tilt your head to the left and look at it, it kind of looks like Elvis. He's got his eyes and he's got his hair with a little curl in it. So that's the Elvis operator. And the Elvis operator says, if whatever is on my left is non-null, that's the value of the expression. If the stuff on my left is null, the value is actually the stuff on the right, which would be the 0. So what this will do is it'll say person with nulls dot name, is that null? If so, then this expression is null. Then Elvis says, oh, that was null. The result is 0. If person with null's name is not null, then get the length, and we're good there. And you can chain these together however you want, and this reduces your code so incredibly much and simplifies the way you can read it. In Java, you'd have to have all sorts of null checks. You'd have to say, if person with nulls.name is not equal to null, then person with nulls.name.length, else 0. So it gets really verbose, and it's especially bad if you have a long chain of things. And that would be really easy to happen when you have complex data structures. Now, sometimes at that point, you might want to say, well, if it's null, that's an error. And so instead, what you might want to have here is a throw and then some exception here. And generally, what you want to do is try to pick the Kotlin versions of the exceptions rather than the Java versions. And we'll say here, name should not be null here. And so what that'll do is it'll throw an exception and boom, you're dead. The program won't continue after that point. Unless, of course, you have a try-catch block around it. I'm not going to go into those details. The try-catch works virtually the same as it does in Java. We currently don't have any type of multi-catch blocks like you do in Java, so you have to explicitly specify them. But one note on exceptions here. Exceptions in Kotlin are all non-checked. And this is one of those features in Java which a lot of people aren't super familiar with how Java works with exceptions. There's two types of exceptions in Java, checked and unchecked exceptions. The checked exceptions are ones that are, well, actually, let me go the other direction. The non-checked exceptions are the ones that are underneath runtime exception or error in the hierarchy. So in neither of those two areas, an exception is considered non-checked. And that means you don't have to put a try-catch around it, and you don't have to add a throws clause inside Java. Any other exception is considered a checked exception, and you have to explicitly put a try-catch around it, or you have to declare that your function throws it. And that was their idea on making sure that people handle exceptions that are important exceptions to handle during a program. Checked exceptions were considered things that are recoverable. Non-checked exceptions were things that were non-recoverable. So those are basically, the programmer screwed up versus the data was bad. Over time, this became an incredible burden, especially if deep inside of a call chain, you make a change that requires an exception being thrown, because then that exception has to be propagated all the way back up the chain. And so what a lot of people, like myself, would do is wrap everything inside of a runtime exception so that you got out of that checked requirement. Well, fortunately in Kotlin, everything is non-checked, which means you don't have to do any of that type of fiddling around. Now, there are a few spots where that's going to get you into some trouble, where you were used to having that check as kind of a support for you to say, the compiler telling you, hey, you need to check this. It's actually an exception coming out. You're not going to get that anymore. So you just have to know if an exception's coming up if you care to catch it. One of the places where that's going to catch you the most is probably with an I/O exception. So if you're doing any type of data I/O and you might have an exception there, you may not think to do the try-catch on those. And that was actually one that was kind of good to catch in Java. There may be some lint tools that somebody will create to help with that at some point. But in general, it's been fantastic in Kotlin not to have checked exceptions. So now let's step into some ideas on how you would pass in functions that you might want to use as callbacks, maybe as observers and things like that. And I'm going to come over here onto the Java side, and let's first of all do a couple examples on the Java side for how you might respond to clicks on a button. So let's say we have class button over here. And inside here, I want to have the button recognize when it's clicked and tell you that it's been clicked. So the tell you part, we're going to do by defining an interface. I'm going to call it onClickListener. And inside here, I'm going to have a void onClick. Wow, I wish I could type today. And we'll say button button, so we know which button was actually clicked. And then inside my button, I can set up that onClickListener. So I can say private onClickListener, onClickListener. We're just going to let him initialize to null. Note that in Java, everything gets initialized to a null or zero-like value, whereas in Kotlin, you have to explicitly specify initializers unless a property is a derived property and doesn't have a backing field. So now I'm going to have a getter or a setter on this one here. Let's create a setter for him so you can actually set it. And then we might have some kind of a function here. If I know that I am clicked. And this is some logic that's inside of your button that's watching for the user touching it. User touches inside me and releases inside me. So that as long as they've started their click inside the button and they end the click inside the button, it doesn't matter if they moved around, that's considered a click. And if that's the case, I want to tell that click listener, so onClickListener.onClick, that the button's been clicked. So this is a little example of how the observer pattern might work. We have the button, which is our observable, and we have this interface, which represents an observer. And so now if we want to actually use these, we'll define a little main function inside here. I could say button1 equals button. Oops, new button. That's a little subtle difference in Kotlin versus Java. In Java, you need to say new when you're creating an instance of something. In Kotlin, you just have the class name paren. And one thing that's nice about that is that actually leads into some scenarios where you can create kind of pseudo constructors as just a function. And sometimes you'll see people create functions with an uppercase name that matches a class name, and it's treated like an alternate constructor that wasn't defined inside the class. So now I can say button1.set onClickListener, and I need to pass in whatever type of onClickListener I want to define. So maybe inside here, I defined a class ClickListener1 implements onClickListener, and we'll implement the method inside there, and maybe I'm going to do a system.out.println clicked, something like that. So I can do this by saying new ClickListener1. Whoops, my main is static, so this actually needs to be a static class. There we go. So there's my ClickListener1. I've passed that in. Now in Java, this was a little bit of an awkward thing where you had to explicitly define this really verbose class for a really simple action on a button. And you had to do this over and over. You're never going to reuse this code. So they came up with the concept of anonymous inner classes. So instead of this, we could actually say new onClickListener and define it in line. And this syntax, new interface, and then the details, is a way to say I'm creating an instance of some class that implements this interface, and here's the details to it right here. And so what we do inside here is something similar to this. I'm just going to say anonymous clicked. And over time, this again is a very verbose syntax, and it's pretty gross. Notice at the end here, this curly paren semicolon. I always like to explicitly put those together like that, which is super ugly. But whenever I was teaching anonymous inner classes, I like to call that out to say, do that so that it stands out. Somebody's going to see it and say, ooh, this is ugly. Maybe there's something special going on here. So that's kind of my intentional way to say it's the end of it. But over time, they added lambdas to the Java language. And anytime you have an interface, so this interface here, the onClickListener, there he is. Anytime you have an interface that has a single abstract method in it, single abstract method, this is called a SAM interface. And a SAM interface, sometimes people call it a functional interface, is an interface that represents a single function. Anytime you have that, you could replace the call to it using a lambda in Java. And this started in Java 1.8. So we can take this same syntax, and if I come in here and just hit Alt-Enter, I can replace it with lambda, and boom, now I have a much cleaner way of specifying that action. So the lambda that's coming in here has an argument button and some code that's being executed. In this case, the code that's being executed is a single statement. So I can put it in just like that. If it were multiple statements, or if you preferred, you can put it inside curly braces, but note I'm going to have the semicolon on the end. And then you could have other statements inside there like that. So the lambda is just a shorthand way of specifying this anonymous inner class. So you don't have to have all the plumbing around it to say which type it is, because it knows the type based on what the argument this function is expecting. So this lambda takes in that information and prints it out. Now there was one problem with this. Lambdas kind of felt like closures in other languages, but they're not. A closure actually captures the surrounding environment, including any variables. And in Java, they didn't have any way to do that. So what they did is on the anonymous inner classes, when they defined them, they set it up so that if you use any variables, it makes a private copy of that variable. So for example, if I came up in here and said I have int x equals 42, and maybe inside here, I wanted to print out x as well as this. What it does is it actually makes a copy of that integer inside of here, and it makes it implicitly final. The way it does that is that it says if it's being used inside here, because I don't actually capture the environment, I'm just making copies, I want to make sure that nobody ever modifies this. Because somebody could come along here and say x++. And now it totally depends on when this anonymous inner class is actually being called, which isn't being called right at this point. It's actually going to be called when the button's clicked. So if I set it up like this, and this x is modified, this guy's got an old value of x. And you'll see here, if I float over it, he's saying variable x is accessed. He needs to be final or effectively final. If I don't change it, that marks it as effectively final, meaning somebody isn't changing the value ever. If you change it, then you get this error inside saying, sorry, I can't do variables here. I have to have things that are values. They're constants. They stay a fixed value at that point. So this is one thing that was a little bit of a problem with lambdas inside Java. They really aren't closures. Inside Kotlin, we have lambdas that are proper closures, so you could do something similar to that. So let's take a look at what we can do on the Kotlin side to make a similar scenario to what we just defined. Let's come up here. I'm going to create a class button. And let's do this. Let's call this button 1. And I'm going to do the same kind of thing. I'm going to say interface on click listener. And we'll define a fun on click, taking a button 1 like that. And then inside my button 1, I'm going to define that same kind of private, well, I don't need to have the separate private field. I can just say var on click listener is an on click listener like that. And this will allow somebody to set it from the outside. It'll also allow it to get it. Over here, you'll notice we didn't have a getter. So I've defined this, and somebody can set it from the outside. Now, one thing to note is that the getter has to have the same visibility. You can't hide the getter. So they'll get the getter for free. It really doesn't hurt anything here. But if, for example, if we wanted to make the setter private, I could come in here and say private set, which would allow me to only change it from inside the class, but it's still publicly gettable from the outside. That can be really useful in some scenarios where you just want to internally change some values, but externally somebody can get the data. So we'll notice here that this lists an error. Because I'm using a backing field, and by default, you get a backing field for free when you define a property, I have to initialize it. So if I float over this, it's going to say property must be initialized or be abstract. So in this case, we have to decide two things. Do we want to represent this as a nullable expression, or do we want a nullable property, or do we want it to be non-nullable? Let's go ahead and say nullable for right now. And I'm going to initialize it to null. And boom, we now have our click listener. So now I'm going to copy this long function name over here. And we will say private if I know that I'm clicked. And inside there, we'll do that same kind of thing here. I'm just going to copy that little comment. And then inside here, I'm going to say if onClickListener is not equal to null, then I want to call onClickListener.onClick, passing in this. Now, there's a couple issues here. We're going to notice that it's flagging this onClickListener with an error here. And it says SmartCast to onClickListener is impossible because onClickListener is a mutable property that could have been changed by this time. This is fantastic. One of the things that's really hard to do in Java is to know when you're going to be in trouble if you have multiple threads acting on you. If you have multiple threads going on, it's possible that at this point, onClickListener was actually not null, but between this line and this line, some other thread has changed the value. So in this particular case, you'll see, that we checked it here, that's fine, but at this point, boom, it could be null again. And that's a problem. Kotlin's really good about what they call smart casting. A lot of times when you check things, it'll say, oh, once I've checked it, I now know that something's nullable or not. And to fix this, what we can do is say val static onClickListener equals onClickListener. So we can capture the value. Notice that we're taking this mutable value and capturing it as a value right there. So static onClickListener can't change. So I'm going to change him to be in both of these spots. And notice here that at this point, static onClickListener is going to be a nullable onClickListener because he's just copying him. That's the type that he infers. If I hold down Control and float over him, it's going to tell me what the type of him is. So you can see that static onClickListener is a nullable onClickListener. But if I move inside this block, Kotlin now knows, oh, you checked it's non-null. Inside of here, float over this, he says SmartCast to onClickListener. Note there's no question mark on the end of that. So he knows that inside the block, it's not null. And that's fantastic. It really reduces a lot of your code. But notice how we got these little squiggles on here. It's giving us a little bit of information in here. What we can do, if I float over, it's going to tell me it's a foldable if-then. We can replace the if with a safe access expression. The safe access expression is the question mark dot. So if we look at this, we can replace all of this with a onClickListener question mark dot onClick this. And what this is going to do is this expression, as it gets evaluated, looks at onClickListener. If it's null, I'm going to skip everything else after it. Boom, I'm done. If it's non-null, I'll take the value of that expression that's been evaluated and then apply the onClick to it. Boom. This is the type of code saving you get versus Java. You can make nice, concise expressions out of this. Now we could also take an approach here. Instead of using nulls, we could use what's called a null object. So it's a dummy implementation of this interface. It just doesn't do anything. And that might look something kind of like this. Class null onClickListener. This is a design pattern that's pretty common. And I could say he's an onClickListener. And his onClick just doesn't do anything. It has an empty implementation. So in that case, up here, let's create a button 2. Actually, that'll be a problem because of this parameter coming into this guy. He wants a button 1. So let's do I'll just inside my button 1 have a second, if I'm unclicked, so we can see what this looks like. And we also need a second onClickListener, unfortunately. So we can have a non-nullable one. And that might look like this. Equals null onClickListener, bloop, bloop. Now take this a step further. The null onClickListener, we only ever need one of them. We never need to create multiple instances. Here, this is going to create a separate instance of the null ClickListener for each instance of the button. In Kotlin, we can make this an object, which means there's only ever one of them. It acts as a singleton. So it creates this object called null onClickListener, and now we don't create an instance, we just use it. And that works perfectly fine. So inside of here, Now I never have to worry about nulls because it's not nullable. So inside here, I can just always say onClickListener2 onClick. Boom. And if it's the null onClickListener, just won't do anything. So this is an alternative to using nulls, using a null object pattern. So let's look at what the calls to this would look like. This is button 1. Let's come down to our main. Where'd my main go? There's my main. Let's say val button 1 equals button 1. And then let's assign the class there. So we can say button 1 dot onClickListener. Let's use the first one for now. Equals something. So we need an instance of a class there. Let's say class onClickListener. I'll say my onClickListener1 is a onClickListener. Implement his function there. We will do a println pressed. And then we can say my onClickListener1. Boom, just like that. And that'll work perfectly fine. That would in fact work for either of those my onClickListener approaches, the one that's nullable or non-nullable, because it's just the same implementation. But we're verbose here. What we'd like to do is be able to implement that. First of all, let's take the anonymous inner class version. So in Kotlin, the equivalent of the anonymous inner class is going to be an inline object definition. So I could say object colon onClickListener. And then, let's get the right place there. We implement members. We'll do the same kind of thing here. And this is the equivalent of an anonymous inner class in Java. It's a little verbose, and there's better ways to do this, but this will work. If you ever have more than one function inside an interface, you'd have to go this approach. If the function is a SAM interface, you don't need to do this. You can actually use a lambda expression for it. Now, there's one little gotcha in Kotlin. If you use an interface for this, you can't use a lambda for it unless you make that a functional interface by putting the word fun in front of it. And what that does is it allows you to replace it with a lambda if you'd like to. And this will only work when there's a single abstract method inside of here. So let's come back down to here. And now I can say, instead of all of this thing, I can define my lambda. But not quite still. When it's a functional interface, you need to do something that they call a SAM constructor for it. And so in here, I'd say onClickListener in front of it. And boom. Now we have a lambda here that takes in a button, but we have to explicitly qualify the type of it. So this isn't normally how you'd want to use a lambda in Kotlin. In Kotlin, you want to use something called a functional type to specify that. And this is where things get so much more nice and terse. Let's go up and create a new version of our button. I'm going to call it button 2, so we can get rid of some of our old baggage here. And in button 2, instead of using this interface for my onClickListener, I'm going to define it as a functional type. So I'm going to have some functional type definition inside the parentheses here because it's nullable. And let's say that we have a single argument coming in, which is a button 2, and we're not returning a value, so the return type is unit. So this is the functional type definition. I had to surround it in parentheses to make it nullable, because if I just said this, then it says the return type is a nullable unit. So here's my functional type definition. Parens with the parameters, arrow, and then the return type. So that's all I need is some function that takes a button and doesn't return anything. So now this know that I'm clicked thing has to change just slightly here. So if we took this first approach here, where the static onClickListener is not null, instead of saying dot onClick, I just get rid of the parentheses. Oh, why do I have the semicolon there? Ew, I accidentally typed a semicolon. Gross. Probably because I copied the line from Java. So we'll see inside here, I just call it like a function now. Down here, it gets a little trickier because of that null safe operator. Because I'm using this null safe operator, I can't just say paren like that. I have to say invoke. And invoke is the way that you can explicitly call a functional type. So this is how you could do it for a nullable version of that. Now, if instead I wanted to have it be non-nullable, I can replace this by saying I'm a function that takes a button and doesn't return anything, and actually the button 2, right? And I just have an empty lambda there. Boom. So now down here, I can explicitly always just say on click listener 2, passing in this. Nice and simple. So now when we go down and take a look at the call to him, let's come back to the main. Let me just search for the main there. There we go. So down in here, if I create a button 2, and then I say button 2 dot on click listener equals my little lambda like that. And of course, I can still do the same thing for that on click listener 2. Both of those work exactly the same. And this is much, much cleaner. Now, if you notice here, IntelliJ is giving me a little bit of a hint here, saying that there's an argument coming in called it. Now, if you don't explicitly list an argument name at the beginning of your lambda, and the function only takes a single argument, it implicitly calls that it. So I could do something like $it on here to print out the button name. Or let's say I don't have a name on it, but it'll print out all the button information using the toString. For this guy down here, let's explicitly name this. I can say button arrow. And now I've explicitly named that initial button. But notice I'm not using it, and it tells me here it's not used, and it could be renamed to underscore. So I could explicitly just say underscore, saying, yeah, I have an argument coming in here, but I'm not using it, just to try to clarify to whoever's reading the code that the argument doesn't matter. If we wanted to use it, I could say $button, just like that. The it will only work if it's the single sole argument to that function. If you had more arguments to the function, so let's come up to our on-click listener here, and let's say that we changed it a little bit. Let's go to this one here. Let's call it on-click listener 3. Now let's say that there were 2 arguments, a button and an integer representing how many times it's been clicked so far. So maybe we have a private var clicked times equals 0, and then we can pass that in here. Maybe I could pass in a little information there to say which button and click times. These are optional and they don't make any difference in the caller. The caller can call them whatever they want. It just might be useful for documentation here. Let's call this click listener 3. We could do something kind of like that where it takes in 2 arguments. And so maybe this one here, I probably should have put it down at the bottom, but I'll put it up here at the top. I know that I'm click 3. He's going to say clicked times plus plus just to increment it, and then pass him in as this and clicked times. And so now if I go back to my main, I can come down here and say on click listener 3, and notice that it's giving me a problem because I only have a single argument defined here. So I have to say this other argument here was clicked times, something kind of like that. And that should allow me to actually figure out how many times the button is clicked. I have multiple arguments. Now I can no longer omit the arguments because there's more than one. The only time you can omit them is if there's exactly one and you don't mind it being called it by default. Now let's take a look at another way we could have handled that situation with checking for null in the first button. So this one here where I have this if block here where I capture a variable and then check the variable. A much cleaner way of doing that is to use what's called a scoping function to define this. So I could say on click listener question mark dot let and then come inside there. And let is a function that takes a lambda as its only argument and a receiver in front of it. So I guess before I talk about that, let's talk about extension functions for a minute. Let's say that we're outside of a class and we want to add something that looks like a function to make it easier to use. I could define fun button1 dot do something and have some code in here. And what's going to happen is if I use this inside of there, this is actually a button1. And I have access to any of the public data from button1. I can't get to the private data, so it's not really adding a function to button1. It's all syntactic sugar, but it would feel like I have that button1. So if I were inside of some other function, up here where I have this button1, I could say button dot do something. And now I have an additional function available on button that I can use in a chain. And the main reason this is really useful is that I can chain these calls together. You know, maybe that do something returns a value. So maybe he returns a string that's nullable. And I could say return Scott or something like that. And then up here, I could do things with that as a chain of operations. If instead I had to check if the button is null first and then call it, making a chain like this ends up having a huge if then else statement. So sometimes this is a really nice way to reduce the code around something and make it feel like you've defined extra functions against something. That said, if I come down to, where was he in my button1, where I'm using this let is an extension function on any type of object. Let's take a look at him real quick. In this function, don't worry about the generics. It's basically just saying I can have anything and anything there. If I have some type and I say dot let, pass in a lambda. So notice here's a functional type saying I'm taking that type, I'm returning some return value. This let block will act as an extension function on top of that object. And what it does is it takes the object and passes it in to that block, which is really, really nice here. What I can do is say take this value, and first of all, the question mark dot says if I'm null, completely skip the let. I'm not going to use it at all. If I'm non-null, then that's going to become my receiver into the let. So this let can use this value, and let takes that value and passes it in as it into the lambda. This is a little bit different than if I said apply. And if I say apply, notice that the receiver for the lambda is this. So inside of here, if I use the it, I could say it passing in this. It did on click passing in this. And at this point, it is definitely non-null. And you'll see over here the hint says it's non-null. So I've come in, I'm using it as non-null and doing something with it. Now, the way I've written this right now, I could just collapse this into this call. It's exactly equivalent. But maybe I want to do some other things in here. Calling the click listener. So I can now do a bunch of things with that value. And basically what we're doing is capturing the value just like we did up here, but it's being called it inside here. I could, of course, use a different name for it, like listener. And now I've captured the value as that listener. The same way that I captured up here as static on-click listener. So that can be really, really useful. Most of the time, people use let for a equivalent of checking if something's non-null and doing something with it. So it's exactly the equivalent to what we did up top here. But you can use it for other purposes. If you want to have some expression that's a longer expression and then just assign a variable to it and not have that variable pollute your namespace. So if we did something like, let me go down to the main to do this. So we have our person with nulls. Let's say we had, let's do the person without nulls. So I could do something like person without nulls dot name dot let and say name inside there. Maybe I want to do multiple things with that name, but I only want to grab it once. So then inside here I could say println name dot length name dot, oh, it might be another thing here. Oh, we'll print the hash code out. Why not? There's a bunch of things we could do with a string. If it were a more complex object, it would make more sense. But if you want to do multiple things with it, this is a way, instead of saying val name equals blah, 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 and then doing these things, we can do this block. And now we don't have any type of extra variable polluting our top level namespace, just to hold on to that name temporarily. Now back up in here, apply is really useful for initialization. That's the main time people use this. And let's actually not use it inside here. Let's go down to our main again. And let's take a look at one of these people. So I have a person here, a person there. I don't have a person that doesn't have data inside of it. Let's actually do a class person with no constructor. And then inside there, I'm just going to define the properties inside of it. So you'd have to explicitly define these properties afterwards. So I need to give them dummy values to start with. So a lot of times you're going to have an object that needs initialization afterwards. Maybe it doesn't have a constructor. Maybe there's other calls you want to make to initialize parts of it. What's really useful is if we say val person 42, I'll call him, because I don't know what my count was up to right now. And I'll say person with no constructor. I can use .apply to do my initialization. What apply does is it takes the receiver and passes it in as this to the lambda, so I can just use it directly. And then at the end of the apply, returns that same value, that same person with no constructor. So what it essentially does is says person to 42 is going to be this guy with these initializations applied. So think of apply as being an initializer. So I can come inside here and say name equals Scott, age equals 54, something like that. And you'll see this happen in many, many different places. This is a crazy useful way to initialize things when you're defining properties inside a class or inside a variable or inside a function like this. Now there's tons and tons of other things I could talk to you about the Kotlin language, but I just wanted to get you some of the basics in here, and we're going to cover some more of the details as we go through other modules in the course.